In the silent void beyond our blue cradle, starlight falls gently on the dust of distant worlds. For millennia, humanity could only gaze up at the night sky in wonder. Countless generations whispered stories about the lights above, never knowing if we would touch them. Yet, in time, we found the courage to step off the shores of our home and into the cosmic ocean. As the 22nd century dawns, those ancient dreams are becoming reality. Humanity is no longer bound to Earth. We are learning to live among the stars. The journey began with a single burst of flame and a leap into the unknown. The first people to slip the bonds of Earth did so in fragile spacecraft, riding pillars of fire into the heavens. In the mid-20th century, a new chapter of our story opened, one in which humans would leave their home planet, if only for moments, to venture into the darkness beyond. On a chilly morning in 1961, a lone cosmonaut named Yuri Gagarin smiled as he became Earth's first emissary to space. His small capsule carried him around our planet in a breathtaking orbit, just above the bright blue curve of the atmosphere. He saw dawn and dusk chase each other across Earth's surface in a matter of minutes, and he returned a changed man with a simple message. Looking at our world from above, he said, we must cherish and preserve this pale blue dot. Not long after, human footsteps pressed into the grey dust of the moon. In 1969, on a silent sea of lunar plains, two figures in white suits bounded in low gravity beneath a black sky filled with stars. The world watched in awe as Neil Armstrong's boot left an imprint on ancient ground untouched by life. That's one small step for a man, one giant leap for mankind, he radioed back, his voice crackling across 250,000 miles. In that moment, the barrier between Earth and the rest of the cosmos was broken. We had set foot on another world, under the harsh sunlight, with Earth hanging in the sky above the barren horizon. Humanity realized both how far we had come and how far we had yet to go. Those first voyages beyond Earth were bold and dangerous. The early astronauts and cosmonauts sat atop roaring rockets with computers less powerful than those we carry in our pockets today. They flew through the void in metal cans, trusting thin walls to protect them from the vacuum and radiation outside. Some missions ended in tragedy, reminding us that space can be unforgiving. But each success and setback taught us more about how to journey beyond our home. We learned how to navigate without gravity, how to work in bulky suits, and how to survive away from the familiar comforts of Earth's air and gravity. Each lesson was a step forward, a necessary part of growing up as a spacefaring species. After the excitement of the moon landings, humanity turned its attention closer to home, learning to live in orbit above Earth. In the decades that followed Apollo, astronauts from many nations came together to build outposts in space. They assembled the first space stations piece by piece above our atmosphere, creating islands of life circling the globe. By the turn of the 21st century, the International Space Station became a shining example of what cooperation beyond Earth could achieve. Circling 400 kilometers overhead, this science laboratory and home was a place where Americans, Russians, Europeans, Asians, and others lived and worked side by side. Inside its humming modules, crews floated in microgravity as they conducted experiments and witnessed 16 sunrises and sunsets every day. They showed that humans could not only visit space briefly, but stay there for months at a time. With each passing day, life in space became a little more normal, if still full of challenges and wonder. From these orbital outposts, we looked both outward and inward. Through the station's windows, astronauts marveled at the fragile beauty of Earth and the endless black beyond. Space became not just a place of exploration, but a place to call home, even if only temporarily. The knowledge gained from living without gravity, recycling air and water, and dealing with isolation helped pave the way for longer journeys. Slowly, humanity was stretching its limbs, testing its strength beyond the protective cradle of Earth. Even as we maintained a foothold just above our planet, robotic explorers ventured further, reaching out to the Moon, Mars, and beyond. Probes and rovers became our trailblazers to other worlds, photographing alien landscapes and sniffing unfamiliar air. They were the scouts of our species, preparing us for the day when humans might follow. Each image of a distant mountain or dry riverbed on Mars ignited our imagination. The call of the cosmos was strong and persistent. We knew in our hearts that one day we would have to answer it and travel farther than any human had gone before. Our early steps off Earth were hesitant and brief, but they marked the beginning of a grand migration. Like a child learning to walk, humanity stumbled at times, yet kept moving forward. We left footprints on the Moon and built a home in the sky with our space stations. We proved that we could survive outside the cradle, at least for a little while. And with that proof came a growing confidence and curiosity. If we could live in orbit for half a year, why not longer? If we could visit the Moon, why not return and stay? The spark of exploration had become a steady flame, lighting the way to worlds beyond. In these first steps into the void, we also carried our humanity with us, our hopes, our fears, and our drive to find companionship, even in solitude. Early crews talked about the profound silence of space, broken only by their own breath and the hum of the spaceship, and how it made them appreciate the voices of their crewmates. They realized that wherever we go, We bring a piece of home with us in our shared experiences and dreams. Space was no longer just an empty place to explore. It was becoming an extension of our collective home, one that we would learn to furnish with life. Earth was the cradle of humanity, but we knew we could not stay in the cradle forever. Those words, spoken over a century ago by a visionary of the early space age, became a mantra for the generations that followed. With each rocket launch and each new footprint beyond Earth, we rocked the cradle a little more, ready to climb out. And once we found our footing beyond Earth's atmosphere, we set our sights on the next stepping stone in the cosmos. The question was no longer if we would venture out again, but where we would go next. Nearly half a century passed after Apollo, before humans returned to the moon. When we finally went back, it was with a new resolve to stay. In the 2020s, the world's space agencies and private explorers worked together to send astronauts once more to our celestial neighbor. They chose a site at the moon's south pole, a place of stark beauty where the sun skims the horizon and casts long shadows. In the depths of nearby craters, water ice lay frozen in eternal darkness, a precious resource that would become the lifeblood of a lunar colony. At first, the return missions brought only a handful of pioneers, living in a small habitat module that had been pre-delivered to the surface. These early lunar explorers spent their days and nights testing equipment and proving that humans could survive and work here again. They trudged across ground where no one had walked since 1972. Their boot prints the first new marks in the moon's silent regolith in decades. Each excursion laid a brick in the foundation of a dream, not just to visit, but to build a home on the moon. As months and years passed, the outpost grew. Modules inflated or 3D printed from lunar soil were added one by one, expanding the shelter. Astronaut engineers directed robotic helpers to pile regolith over the habitats, forming protective walls against radiation and micrometeorites. Solar panels unfurled on the ridges above, soaking up relentless sunlight to power life support and research labs. Inside the base, people lived in a shirt-sleeve environment, breathing air recycled from what they had brought and what they could extract from the moon itself. By breaking apart lunar ice into hydrogen and oxygen, they made water to drink and air to breathe. Every drop was precious and reused. Every resource on this barren world was treasured. The first lunar settlers lived simply but industriously. Their days were filled with tasks, maintaining systems, tending a tiny greenhouse of leafy greens, and roving outside to explore and gather materials. At night, they returned to the shelter of their habitat and gathered around a communal table, sharing stories and a few comforts from Earth. Through a small window, they could watch a blue Earth rising and setting in slow motion. To them, Earth was a bright beacon hanging above the desolate horizon, a constant reminder of home and of the significance of what they were building on this grey frontier. As the lunar base proved its worth, it began to attract more investment and talent. What started as a small research station evolved into a true settlement. By the late 2030s and 2040s, there were semi-permanent crews and even discussions of families joining the moon community. Engineers, scientists, miners, and doctors took turns serving at the outpost, and some eventually made the moon their long-term residence as supply lines became reliable. The base became an international village of sorts, an endeavour not claimed by any one nation, but shared by all. New modules were constructed to house laboratories, workshops, and living quarters. There was even a compact gym where colonists ran on treadmills and lifted weights with resistance bands to stay strong in low gravity. The moon's weak gravity, just 1/6 of Earth's, changed daily life in fascinating ways. Heavy equipment could be moved with relative ease, and a person could carry loads that would be impossibly heavy back on Earth. Enterprising settlers started low-gravity games to entertain themselves. They discovered they could jump several times higher than on Earth, bounding like children in a playground. A simple leap over a rock could turn into a slow, soaring vault. In their free hours, crew members would sometimes organize races or improvised sports, laughing as they hopped and glided across the dusty ground, in a place where every breath and drop of water was carefully measured. These moments of play provided joy and a reminder of human creativity. One historic day, the lunar base even welcomed the birth of a child. After years of careful planning and with medical experts supervising closely from Earth, a healthy baby was born under the lower gravity of the moon. The infant's first cries rang out in the sealed habitat, a poignant sound in a world that had never known life. This baby girl became a symbol of a new era, humanity putting down roots beyond its birthplace. Her parents, two scientists who had met on the moon, cradled her with awe. The colony celebrated, aware that this tiny child was the first true citizen of the moon. As she grew, learning to walk in 1/6 gravity, everyone watched in wonder. Humanity had not just travelled to space. We were beginning to live and even raise families there. In the lunar settlement, routines and innovations went hand in hand. Colonists ate simple meals, mostly brought from Earth or grown in small indoor gardens under LED lights. They kept to a schedule loosely synced with Earth days, though the sun might stay low on the horizon for weeks. During periods of darkness, when the sun dipped below the polar peaks, The colony relied on batteries and stored oxygen. Outside, the temperature fell to hundreds of degrees below zero, and the sky was a dome of brilliant stars. Yet inside the habitats, it remained warm, bright, and filled with voices. People read books, recorded video messages for friends on Earth, and taught one another new skills to pass the time. Sometimes someone would strum a guitar or set soft music playing, and the gentle notes would remind everyone of home. By the time the first generation of lunar settlers had spent years on the moon, the base had grown into a small village. It had an infirmary, a communication centre linking it constantly to Earth, and even a corner converted into a school and library for all ages. The settlement became a launch point for new ventures. Teams journeyed out in pressurized rovers to map the land and hunt for new resources, while others began building a telescope on the far side of the moon to peer deeper into the cosmos without interference. Each success strengthened the feeling that the moon was not just a research outpost, but an extension of Earth's civilization, a new foothold for humanity. Each hard-won achievement on the moon served as a stepping stone, preparing us for journeys farther away. Living on the moon taught us how to build habitats from local materials, how to shield ourselves from intense radiation, and how to keep a community healthy and happy in isolation. And as we became at home on our nearest neighbour, we grew bolder and more optimistic about reaching the next, more challenging frontier. With the lunar colony thriving and its lessons in hand, humanity turned its eyes toward a bright red point of light in the night sky. Mars, the red planet, was next. Humanity's attempt to reach Mars was a leap far greater than the journey to the moon. Mars, a distant reddish beacon in our night sky, had called to explorers and dreamers for centuries. Answering that call meant pushing our technology and our spirits to their limits. Decades after establishing a foothold on the moon, the first crewed mission to Mars lifted off from Earth. 6 brave explorers strapped into a spacecraft for a voyage of over 6 months through deep space. During the long cruise, they watched as Earth became just a pale blue star behind them, and Mars grew from a tiny ruby pinprick into a discernible world ahead. They knew that once they landed, they would be farther from Earth than any humans before them, on their own in a way no one had ever been. When the day finally came to set foot on Mars, the world listened intently across the void. A lander descended through the thin Martian atmosphere, buffeted by winds of red dust. Its engines flared, kicking up clouds as it touched down on an ancient plain. The hull settled onto steady ground, and then, after a breathless pause, the hatch opened. The crew's commander climbed down a short ladder, pausing to take in the scene. Rust-coloured rocks stretched to the horizon under a salmon-pink sky. With a deep breath inside her suit, she stepped onto the Martian soil. Her boot sank slightly into the reddish dust. We are home at last, on Mars, she radioed to Earth, her voice crackling with emotion and the faint echo of history. Though her words were simple, they carried the weight of a dream fulfilled. Humanity had finally become interplanetary, planting its feet on a new world. The first days on Mars were a whirlwind of activity and adjustment. The astronauts set up a basic camp using the lander itself and inflatable habitats that had been pre-deployed and waiting for them. They worked methodically, knowing their lives depended on making this barren environment livable. They erected communication antennas to talk to Earth. Each message still took many minutes to arrive. Deployed solar panels and a small nuclear generator for power, and initiated the machines that would extract oxygen from the carbon dioxide Martian air. Every task was critical. Inside their main habitat module, they activated life support systems to generate breathable air and water from their supplies and any local resources they could tap. Each night, the crew gathered around a tiny table in their pressurized living space, exhausted but exhilarated, to share a simple meal and record their thoughts about the strange new world outside. Mars quickly proved both beautiful and harsh. During their first excursion in pressurized rovers, the crew drove across dusty terrain to scout for a suitable long-term base location. The sun was smaller and dimmer than on Earth, but still bright enough to cast sharp shadows on the ochre ground. In the thin atmosphere, daylight had a golden hue, and the sky often carried a butterscotch tint from fine dust. When winds picked up, dust devils spiraled over the plains in the distance, ghostly whirlwinds dancing silently over the cold desert. The explorers marveled at alien vistas, cliffs carved by ancient rivers, the towering bulk of Olympus Mons on the far horizon, and craters that told stories of meteor impacts eons ago. At midday, the temperature might rise just above freezing, but by nightfall, it plummeted far below zero. They would often pause to collect rock samples, searching for clues of Mars's past, perhaps even signs that life once stirred in this now desolate land. Back at the landing site, construction of Mars's first real habitat was underway. Robots sent ahead of time had already 3D printed the shell of an outpost, using Martian soil and resin binders, creating a dome-like shelter, partially buried for radiation protection. The human crew finished the job, installing airlocks, furnishing the interior, and setting up systems to make it a home. Over the following weeks, the outpost became operational. A small but steady oasis of warmth and air amid the cold, thin-aired wilderness. The base had sleeping quarters, a laboratory, a tiny kitchen, and a common area where the team could relax. There was also a greenhouse module where, under magenta grow lights, the first earth plants on Mars put down roots in hydroponic trays. Seeing green sprouts and smelling fresh leaves in that little greenhouse brought tears to the eyes of astronauts who had spent weeks surrounded by rock and dust. Those tender plants were a promise that one day Mars would support gardens and maybe even fields. Living on Mars required adapting to an entirely new rhythm. The Martian day, or sol, is about 24 hours and 40 minutes, just slightly longer than Earth's day, so the crew found their bodies adjusting easily to the extra minutes, joking that they had Mars-long weekends every week. However, the Martian year is nearly twice as long as Earth's, which made the passage of seasons slow and subtle. They arrived in the relative warmth of spring, and as months went by, they watched the weather change. Thin frost sometimes appeared on the ground at dawn. Over time, they witnessed something truly astonishing, a global dust storm creeping over the horizon. The sky darkened with fine red particles until the sun was a mere dim glow. For weeks, the colony was shrouded in a rust-coloured twilight, even at midday. Solar panels struggled, so the base switched to reserve power and carefully rationed energy. The crew hunkered down, conserving resources and keeping each other's spirits up during the long Martian storm night. When the dust finally settled and the sun returned, the base had endured its first Martian storm, and the crew emerged wiser and more prepared for the planet's moods. As the years progressed, more missions brought additional crew and supplies to Mars. What began with 6 explorers grew to a community of a few dozen, scattered between a main base and several smaller outposts. Some outposts were established near subsurface ice deposits, where automated drills could extract water for the settlements. Others perched on high ground, serving as communications relays or scientific stations to monitor the Martian climate and geology. The main colony, though still modest in population, became a hub of human activity on Mars. It featured interconnected living modules, workshops for repairing equipment, and even a small clinic. The walls of some habitats were reinforced with bricks made of Martian soil, adding to their protection and permanence. Over time, structures grew more sophisticated and spacious. Tunnels were dug to connect buildings, providing sheltered pathways out of the biting cold and shielding colonists from cosmic rays when moving about the base. By burying sections of the habitat complex, the colonists created cozy underground rooms, insulated from the extreme temperature swings, a bit like living in a network of modern caves. With more people came a semblance of normal life, even so far from Earth. A typical day on Mars might start with a shared breakfast in the main dining area. perhaps rehydrated eggs and vegetables, plus coffee brewed from beans that had been brought from Earth or grown in a hydroponic bay. Conversations ranged from repair schedules for the rover fleet to excitement over a new scientific finding, to friendly banter about whose turn it was to clean the dust filters. Each person had a role. Some were engineers keeping the life support and power systems humming. Others were scientists analyzing soil samples for traces of ancient microbes or studying the planet's weather. Medics monitored everyone's health under the stresses of lower gravity and higher radiation, and agricultural specialists tended to the greenhouse, coaxing more growth from the limited seeds and soil. After breakfast, teams suited up for EVA, extravehicular activity, tasks. Stepping out onto the surface in their armoured suits became almost routine, though Mars never lost its wonder. Even the chores, like clearing wind-blown dust off solar panels or maintaining the oxygen generator, came with a view of alien hills under a pink sky, a backdrop that made even tedious work feel meaningful. Despite the workload, the settlers found moments to appreciate the profound uniqueness of their situation. In the evening, some would climb a small ridge near the base to watch the sunset. Martian sunsets are surprisingly blue. As the sun dipped low, the dust in the air scattered the light in such a way that around the fading sun a cool blue glow appeared. It was the opposite of the warm orange sunsets on Earth, and the colonists often fell silent watching it, reminded that they truly were on a different world. As dusk deepened, the stars began to prick through the sky, and two tiny moons, Phobos and Deimos, would make their swift trek overhead. The colonists would point out where Earth would be in the sky, often below the horizon at night, but sometimes visible as a bright star-like point. In those moments, they felt both the distance from home and the closeness of their tight-knit community on Mars. Over several launch windows, Mars grew into humanity's second off-world home. There were setbacks and triumphs. A particularly rough dust storm one year taught them to build more robust backup power systems. The successful drilling into a rich ice layer was celebrated with the first long, luxurious showers for everyone. As infrastructure improved, talk began about the future. How to make Mars not just an expedition site, but a self-sustaining world. Some dreamed of terraforming, brainstorming grand schemes to warm the planet and thicken its atmosphere over centuries. Others focused on the near term, expanding living space, improving transportation on the surface, perhaps even planning a city for the next generation. Though small, the Mars colony stood as a testament to human determination. It stretched our ingenuity, our cooperation, and our courage to the limit. And then a bit further, standing on the rusty sands of the red planet, humans had become not just visitors, but residents of a world once thought unreachable. And as they looked up at the night sky, seeing the faint glimmer of Earth among countless stars, those settlers knew this achievement was not an end point, but a milestone on a much longer journey. Mars was a new beginning, and even as we settled into life there, humanity's gaze was already turning in another direction. Beyond Mars and the other planets lay the vastness of space itself, and some among us asked, could we live not just on worlds, but in the space between? Not all of humanity's new homes were on planetary surfaces. In fact, some of the most remarkable settlements were constructed in the void itself, habitats orbiting Earth and other celestial bodies, where people could live in space indefinitely. As our rockets became more reliable and frequent, and as living in microgravity became better understood, the old dream of space colonies took real shape. What once was imagined in science fiction, cities in the sky, started to become reality in the latter part of the 21st century. The earliest orbital habitats were modest, expansions of the space stations that had circled Earth since the 20th century. Private companies launched commercial modules, including one that served as a hotel, where adventurous tourists could stay for a week or two, gazing down at the blue Earth turning below. These were small steps, but they proved there was a demand and desire for life in orbit beyond government-run science labs. Entrepreneurs and international coalitions alike set their sights on building something bigger. Stations where hundreds, even thousands of people could live, work, and perhaps one day raise families without ever touching a planet's surface. Building a large habitat in orbit was a daunting challenge, made possible only by using resources beyond Earth. Following the vision of earlier space pioneers, engineers began utilizing materials mined from the moon and asteroids to construct enormous structures in space, reducing the need to lift everything from Earth's gravity well. One of the first mega projects was a rotating ring-shaped station, a gleaming wheel slowly spinning against a backdrop of stars. Its rotation created a gentle artificial gravity along its outer rim, enough to let occupants walk comfortably and live in a more Earth-like way. Inside, this station had decks and compartments like a giant cruise ship, complete with living quarters, laboratories, gardens, and open areas for recreation. Walking inside one of these habitats was a surreal experience at first. Imagine strolling through a park with grass and trees, under an arched sky that is actually the ground curving up above you in the distance. In some designs, enormous windows in the cylinder's sides let in sunlight reflected from mirrors, creating a cycle of day and night for those living inside. Residents could look up or out through those windows and see the cosmos directly. One moment, the glittering expanse of stars. The next, the distant blue marble of Earth, or the pearly glow of the moon coming into view as the habitat turned. Many found it breathtaking and a bit disorienting, a reminder of both how bold this venture was and how small our home planet appeared from afar. Life in an orbital habitat blended the familiar with the fantastic. People still lived in apartments or dormitory-style rooms, went to work or school, and gathered for meals. But their neighborhood floated in space, and their streets were curved hallways following the inner circumference of a rotating drum. In the larger colonies, there were cafes where you might sip coffee while watching Earthrise through a window. Children played in zero-gravity chambers at the station's hub, giggling as they floated freely like tiny superheroes, then returned to the outer sections where spin gravity let them run and jump in a more ordinary way. Parks with real soil and small ponds were carefully tended under artificial weather systems. Some habitats even managed to sustain birds and butterflies in these green spaces. Their gentle chirps and flashes of colour bringing a touch of Earth's wilderness to life in orbit. As technology advanced, orbital habitats became larger and more ambitious. By the 22nd century, plans were underway for massive rotating cylinders known as O'Neill colonies, named for the 20th century physicist Gerard O'Neill, who imagined them. Each cylinder, if completed, would be miles long and capable of housing tens of thousands of inhabitants. Even in our time, at least one such colony has begun construction at a stable Lagrange point between Earth and the Moon. It floats where gravitational forces balance. A new world being assembled piece by piece. Robotic construction vehicles ferry raw materials, metallic ore from asteroids, water ice from the Moon for life support, while human engineers and AI overseers supervise the assembly of this artificial paradise. Inside these colossal structures, architects design landscapes that mirror the diversity of Earth's environments. One section might look like a terraced hillside town with cottages and gardens stepping up the curving interior, while another section might be devoted to agriculture, with rows of crops basking under carefully tuned light. There might be an interior lake, essentially a broad reservoir at the center of a cylindrical habitat, providing both water and a picturesque vista, its surface conforming oddly to the curved, spin-generated gravity. Living in such a place sometimes felt like being on a very large ship or island, except the horizon wrapped up and over your head. It took time for inhabitants to get used to the idea that up would eventually be down if you walked far enough around. The people drawn to orbital living have been as varied as those on Earth's surface. Scientists and engineers were the first, maintaining the stations and conducting research in the unique microgravity and vacuum conditions available outside the rotating sections. Then came entrepreneurs operating factories that used microgravity to manufacture ultra-pure pharmaceuticals and crystals impossible to create on Earth, as well as new alloys and biological tissues cultivated free from the stresses of weight. Artists arrived too, inspired by the novel environment. Some created sculptures that floated in the weightless central hub of habitats, slowly drifting works of art that could never exist under gravity's pull. Musicians composed pieces that echoed the gentle rotation cycles or the hum of air recyclers, finding muse in the rhythms of life in orbit. Families eventually joined, especially in the larger colonies where life could approximate an Earth-like routine. Children in these habitats grew up with the extraordinary normalcy of calling a space station home. They had favorite climbing trees growing in parks under an artificial sky, and they'd catch ladybugs or fish in ponds that encircled entire levels. Of course, living in orbit came with challenges. Cosmic radiation was an ever-present concern, as it was on the Moon and Mars. Habitats were built with thick shielding, sometimes layers of water or special plastics lining the outer hull to absorb radiation. Some designs even banked soil or asteroid rock around living areas to mimic the protection of Earth's atmosphere and magnetic field. The spinning that provided gravity had to be carefully engineered. Too slow a rotation, and people would feel lightheaded from low gravity. Too fast, and they might experience dizziness or inner ear problems. Engineers eventually settled on rotation rates and diameters that most people found comfortable, and over time, residents hardly noticed their world was spinning at all, except when a newcomer's inner ear needed a day or two to adapt. There were also psychological adjustments. Being in a large habitat is different from being on an open planet. No matter how spacious, it's still a defined volume with edges you could ultimately reach. To keep life feeling open and free, habitat designers incorporated long sightlines and communal gathering spaces. High ceilings, broad internal boulevards, and even simulated horizon lines or distant features painted on interior walls helped create a sense of normalcy. One habitat had a famous sky mural on its ceiling, expertly painted to give the illusion of clouds and depth beyond the actual structure. Another managed a daily rain in its central park, a light misting that watered the plants and gave residents the soothing sensory experience of a rainfall, complete with the fresh petrichor scent afterward. People would sometimes go out of their way to walk through that park during scheduled rain, holding hands or simply listening to the patter on leaves, finding comfort in this recreation of a beloved earthly moment. Transport to and from orbital habitats became routine. Reusable shuttles, some shaped like sleek planes, would depart Earth's surface daily, carrying new residents, workers, or tourists up and returning with those heading back down. space elevators remained a theoretical possibility, too difficult to build with known materials so far. But other innovations, like electromagnetic launch, assist systems, helped reduce the cost of reaching orbit. For the inhabitants above, travel was akin to living in a port city. One could finish breakfast, hop on a transfer vehicle, and be on the moon by evening, or catch a fast transport to a Mars-bound ship departing from a high orbit. Orbital colonies became hubs for this kind of cosmic travel. They were the crossroads, the way stations that connected the planets. Crucially, orbital habitats did not just circle Earth. Similar stations were built around the Moon, serving as construction bases and logistics hubs for the lunar colony. Mars, too, gained an orbital companion, a station where ships arriving from Earth could dock, refuel, or swap crews, and then send smaller landers down to the Martian surface. These orbital harbours made interplanetary travel more efficient and opened up new possibilities. Around distant planets, smaller outposts were established. A research station orbiting Venus here, a fuel depot near an asteroid there. Bit by bit, we created an infrastructure among the planets, a web of outposts and habitats supporting each other. In these free-floating colonies, humanity found a unique kind of freedom. Unbound by the surface of any world, orbiting communities could be positioned for optimal sunlight or moved, slowly, over time, to new locations if needed. They represented self-contained ecosystems, learning to thrive independently. Day by day, some habitats inched closer to the ideal of a closed-loop system, recycling air, water, and nutrients so efficiently that they needed minimal resupply. This technology, perfected in orbit, would prove vital for pushing further out into space, where resupply from Earth was impractical. The creation of orbital habitats not only gave us new places to live, but changed our perspective. People living in space full-time began to see themselves not as belonging to one country or even one planet, but as citizens of the solar system. Their window views encompassed worlds. Their daily reality was the stars. Children raised on a habitat might think nothing of the fact that down was metal and composites instead of soil, and that outside was an airless expanse where one mustn't go without a suit. They grew up celebrating 2 birthdays each year, one for Earth's calendar and one for the number of times their rotating colony had orbited the Earth. Their culture evolved unique traditions, maybe an orbital day to mark the anniversary of their station's founding, or a fun game where kids compete to toss a ball straight enough to make it float in microgravity at the hub. As the population in orbit grew, so did the infrastructure supporting it. Networks of satellites provided high-speed communication, linking habitats with each other and with Earth, stitching all these scattered communities into a single network. If an engineer on an orbital colony near Earth came up with a new design for an air filter, within hours, the plans could be transmitted to Mars's orbit or the Moon's surface and replicated there. There was a constant exchange of knowledge, culture, and sometimes people, specialists rotating through different postings, bringing fresh perspectives to each place they went. By 2125, a significant number of humans lived beyond Earth's surface, not only on other planets, but in habitats they built in the heavens. Each habitat was a testament to human creativity, showing that we could take the void of space and turn it into a living, breathing environment, rich with green plants, flowing water, and the laughter of families. These pioneering homes in space proved that our species could adapt not just to new planets, but to entirely novel environments of our own creation. With orbital colonies flourishing and settlements on the Moon and Mars established, humanity had truly expanded its presence. We were like a growing family, once confined to a single house, now spread across a vast estate of worlds and way stations. Yet even with our new homes scattered through the solar system, the distances between them were immense. The Moon is days away, Mars months away, the outer planets years away. To keep this interplanetary family connected and to push further outward, we needed to go faster. Our next great leap came from reimagining how we travel, from the fire and thunder of chemical rockets to the elegant power of tomorrow's propulsion. In the early days of space exploration, our journeys were limited by the technology of chemical rockets. Those first brave souls orbiting Earth or walking on the Moon did so propelled by engines that guzzled fuel and produced tremendous thrust, but at enormous cost and with tight constraints. A trip to the Moon was like a high-speed sprint, and reaching farther, to Mars or beyond, meant accepting voyages that lasted months or years. As humanity spread its wings across the solar system, it became clear that if we were to routinely travel between Earth, the Moon, Mars, and other destinations, we would need new kinds of engines to make those vast distances traversable in a reasonable time. The distances were simply too great, and the old methods too slow. Thus began a renaissance in rocket engineering, a quest for propulsion breakthroughs to connect our interplanetary society. One of the first breakthroughs came with the return of reusable spacecraft in the 21st century. Visionary companies and space agencies developed rockets that could launch a payload to orbit and then fly back and land, ready to be refueled and used again. This revolution in reusability drastically reduced the cost of reaching space. What once cost a fortune for a single launch became more like an airline operation. Rockets were used dozens of times. This reliability and cost-effectiveness opened the door for more ambitious missions and more frequent supply runs. Without it, building large orbital habitats or sustaining colonies on the Moon and Mars would have remained prohibitively expensive. Reusability was the foundation for everything that followed. It turned space from a rare adventure into a realm we could access regularly. Yet cheaper launches were only the beginning. To shrink transit times and truly open the highways of the solar system, engineers looked to more powerful and efficient propulsion. They revisited an idea imagined decades earlier but never fully realized: nuclear rockets. By the mid-21st century, the first nuclear thermal propulsion systems were tested in space. These engines used a compact nuclear reactor to superheat a propellant like hydrogen, which then expanded through a nozzle to produce thrust. The result was a rocket with roughly double or more the efficiency of the best chemical engines. For crewed missions, this was a game changer. A journey to Mars that might take 6 to 9 months using traditional rockets could, with a nuclear thermal stage, be shortened to 4 or 5 months. Such a reduction in travel time meant less exposure to cosmic radiation for the crew, fewer supplies needed for the trip, and a quicker psychological hurdle, knowing that Earth was not quite so far away. Nuclear thermal rockets saw their first uses in pushing heavy cargo. Space agencies would send large payloads, habitat modules, rovers, fuel, and supplies ahead of human missions using these powerful engines. From low Earth orbit, a nuclear rocket could fire and send a payload cruising out to Mars on a fast trajectory that earlier generations could only dream of. In the following decades, refined versions of these engines were integrated into crewed spacecraft as well, especially for return trips or emergency abort scenarios, where getting home faster could mean the difference between life and death. There was a cautious approach to using nuclear power in space. Great care was taken to ensure these reactors activated only once safely outside Earth's atmosphere, and elaborate safety measures were in place. Over time, the track record grew, and nuclear propulsion became an accepted workhorse for deep space travel. Alongside nuclear thermal technology, we also harnessed electric propulsion in new ways. Ion drives, engines that propel a craft by accelerating ions, charged particles, to extreme velocities, had been used on robotic probes for years. They produce a gentle thrust, imperceptible in the short term, but sustained over months, it can push a spacecraft to enormous speeds. In the 21st century, these became the engines of choice for uncrewed cargo transport. Picture a bulky freight ship leaving Earth orbit, not with a dramatic burst of flame, but with a steady blue glow of xenon plasma from its ion thrusters. It accelerates gradually, day by day, never stopping to rest. Such a ship might take a long spiral path outward, but it does so using only a trickle of propellant compared to a chemical rocket. Solar panels or a small reactor power its ion drives, and it carries perhaps mining equipment to Mars, or water extracted from the moon, bound for a fuel depot in orbit. These solar electric and later nuclear electric propulsion systems turned out to be perfect for moving heavy cargo efficiently. They enabled the pre-positioning of large amounts of supplies, for example, sending 50 tons of equipment to Mars orbit in advance of a human mission, so that when astronauts arrived, they had everything they needed waiting for them. On the Moon, electric tugs shuttled materials from lunar orbit to the surface and back, making the supply chain to our nearest neighbor more like a reliable ferry service than a one-off landing. While ion drives wouldn't win any races in a sprint, in the marathon of space logistics, they were unbeatable. Perhaps the most revolutionary propulsion advance, however, came from tapping into the power of the atom in an even more profound way. Nuclear fusion. Fusion, propulsion, had been a staple of science fiction for ages. The idea of using the same energy source as the sun and stars to drive our ships. For a long time, fusion was elusive. Scientists on Earth worked to create net positive fusion energy for power plants and faced one challenge after another. But steady progress was made, and eventually those advances translated into spacecraft design. By the early 22nd century, experimental fusion engines were being tested in space. These engines fused light elements, like isotopes of hydrogen, to release staggering amounts of energy, which could heat propellant or even be directed as a plasma jet for thrust. A fusion-powered spacecraft promised to cut travel times dramatically. A concept emerged of a fusion torch ship, a vessel that could thrust continuously at a low acceleration, but over weeks could build up speeds far beyond what any short-burn rocket could. Imagine a graceful ship leaving a Mars orbital station, pivoting its tail toward its destination, and then lighting its fusion drive. There's no massive explosion, just an enduring bright exhaust, almost like a small star igniting behind it. It accelerates not for minutes, but for days on end, steadily gaining velocity, slicing through the millions of kilometers. With such technology, a trip to Jupiter's moons, once a decade-long endeavor for a probe, could be done by a crew in perhaps a year or less. A journey to Mars could shrink to mere weeks, fundamentally changing the cadence of interplanetary travel. One notable project was a fusion rocket called Sunward. Engineers envisioned it halving the time to Mars, or better. It had a magnetic confinement system to control the fusion reaction and direct the plasma exhaust, and it was designed to be refueled in orbit using helium-3 from the Moon or deuterium harvested from asteroid water, tying the engine's needs to our developing off-world resource economy. The first full-scale test of a fusion drive in space was met with eager eyes. Telescopes watched as a remote-controlled test craft engaged its engine beyond the Moon. A dim, bluish star appeared where the ship was, indicating the fusion particles streaming out. The craft achieved a delta V change in velocity far beyond what any chemical rocket could, validating that the era of fusion propulsion was dawning. While fusion engines were being realized, other exotic ideas also found their niche. Solar sails, for example, came into practical use for certain missions. These gossamer-thin, reflective sheets could be deployed by lightweight probes to catch the pressure of sunlight. Without any fuel at all, a probe with a solar sail could gradually accelerate away from the sun. Some imaginative missions even used powerful laser arrays stationed in orbit to push these sails, boosting small interstellar probes to incredible speeds, a precursor to one day reaching other stars. For instance, a swarm of tiny sensor chips with attached sails were sent out of the solar system, propelled by laser bursts, becoming humanity's first emissaries to the space between stars. They were not crude, not even large, but they demonstrated that with ingenuity we could reach far beyond our current homes. Back within the solar system, our improved propulsion capabilities transformed our interplanetary society. Trips that used to be rare, epic voyages, like going from Earth to Mars, became more commonplace. When fast, reliable ships can make the journey in a month or two, the gulf between those worlds doesn't seem so uncrossable. The moon became a weekend destination for some tourists, a mere days-long trip on a nuclear shuttle. Scientists commuting between Earth orbit and Mars orbit could do so in a fraction of a year, allowing more frequent rotations of personnel and fresh expertise brought to the frontier. Emergency on Mars. A fast response vehicle with a fusion drive could potentially send help significantly quicker than before. This newfound responsiveness knitted the planets closer together. With faster engines also came larger ships. When you can generate more thrust and efficiency, you can afford to build vessels that are more comfortable and capable. The cramped capsules of the Apollo era, or the tightly packed spacecraft of the early Mars missions, gave way to spacious cruisers. By the late 21st century, there were passenger ships in orbit, fitted with centrifuge rings that created a bit of gravity on board for long cruises, complete with dining halls and viewing ports for the travellers. These ships, often built in orbital shipyards and too large to ever enter a planet's atmosphere, plied the routes between Earth, the Moon, and Mars, making the trip on a regular schedule. For the first time, one could imagine an interplanetary transportation network akin to ocean liners or airlines on Earth, albeit slower and grander. The outer solar system, too, benefited. Nuclear and electric propulsion allowed us to send scientific missions to Jupiter, Saturn, and beyond more readily, and even contemplate crewed expeditions there. While no human has yet stood on the icy moons of Jupiter or skimmed the rings of Saturn, robotic missions multiplied under the new propulsion regime, and serious designs were drawn up for crewed exploration that could become feasible within a generation. A nuclear electric ship with a capable crew might orbit Jupiter's Europa, surveying its cracked icy surface for signs of the ocean beneath. or a fusion ship might carry explorers to Saturn's Titan, that haze-veiled world of lakes and rivers of methane. These were the dreams taking shape as our engines gave us the reach to consider them not in centuries, but perhaps in mere decades. All the same, space travel remained an endeavour of respect and caution. The faster you go, the more careful you must be in aiming and braking. A high-speed ship needs precision navigation and enormous energy to slow down at journey's end. Here, our ever-faithful silent partners, the computers and AIs, played a crucial role, calculating trajectories, monitoring engine performance, and even adjusting mid-course when needed to ensure a smooth arrival. They became the helmsmen of our advanced ships, reacting far quicker than human reflexes could, though always under the watchful eyes of human crew. Our mastery of propulsion is still evolving. Research continues on even more radical ideas. Antimatter engines that could, in theory, provide unmatched energy if we can produce and store enough antimatter safely. Or the nascent, speculative concepts of warp drives and hyperspace jumps, which remain mostly theoretical and on the edge of known physics. While those remain dreams for now, we keep pushing at the edges. The progress we've made, from the roaring chemical rockets to the quiet whisper of ion thrusters and the stellar fire of fusion drives, gives us hope that no door is permanently closed. With faster ships knitting together our scattered worlds, another challenge became apparent: managing and supporting the complex web of human activity in space. Here, we turned to something that had been progressing all along, quietly yet profoundly: the rise of intelligent machines. Our robots and AI systems were the unsung heroes making all these advances possible, operating tirelessly in the background and sometimes foreground of the final frontier. While astronauts and colonists often take the spotlight in tales of space, they would be the first to acknowledge that nothing would succeed without their robotic helpers. These machines have been our companions from the start. Think back to the first rover on Mars, Sojourner, trundling across the Martian soil in 1997, or even earlier, the Soviet lunar rovers on the Moon in the 1970s. They showed the value of having mechanical explorers on the ground when humans could not yet be there. As our ventures grew, so did the sophistication and importance of our robots and AI. On the Moon's surface, under the brilliant glare of an unfiltered sun, one might have seen an autonomous rover busy at work, even when the human crew was resting. These robotic labourers toiled without complaint. They built, they dug, they surveyed. Early lunar settlers fondly gave nicknames to their robots: Little Dipper, for a probe that scouted shadowed craters for ice, or Bruno, for the heavy bulldozer robot that cleared regolith to flatten a landing pad. Bruno, in fact, operated almost around the clock, guided by an AI that allowed it to recognize obstacles and plan paths, shifting lunar soil to create a safe, even surface for incoming spacecraft. While the astronauts slept after a long day, Bruno kept working under the Earth shine, its headlights casting long shadows across the ground. It was steadily transforming. On Mars, before the first crew arrived, dozens of robotic precursors had already been hard at work. They arrived on their own landers, some small, some hefty, carrying pieces of habitats, power generators, and vehicles in kit form. In the months before humans stepped out of that hatch, these robots, coordinated by an AI network, assembled a rudimentary base. They joined habitat modules, connected power cables, deployed solar arrays, and even stockpiled supplies. It was a strange and wondrous sight. Machines building a home for humans on a world where there had never been a home before. When the astronauts eventually came down the lander's ladder, the lights were already on at the base, thanks to their tireless helpers. These robots were guided by artificial intelligences that had grown incredibly adept. Not sentient beings with their own desires, but very smart systems, optimized to handle tasks under conditions far too complex and far away for step-by-step human control. A rover on Mars might have an AI pilot that could recognize interesting rock formations and steer over to investigate, taking initiative when communication delays made real-time control from Earth impractical. On the Moon, construction bots used AI-driven vision to match boulders and regolith to the base plans they'd been given, improvising when the terrain didn't match expectations, and then checking their work with lasers and cameras to ensure everything was secure. The partnership between humans and robots extended everywhere. On the orbital habitats, countless small robots, floating spheres equipped with fans, or spider-like machines climbing along the station's framework, handled routine inspections and repairs. If a micrometeorite punctured a solar panel, sensors would detect the impact, and within minutes, an automated drone would be dispatched to assess the damage, patching small holes or alerting the crew if a larger fix was needed. The human residents might only learn about it over dinner when an alert tells them that a repair has been completed. Often, they didn't need to intervene at all unless it was a truly significant problem. In our spacecraft too, AI served as navigator and co-pilot. Consider a long voyage to Saturn's moons. Much of the journey, the ship's path is fine-tuned by an onboard AI that makes tiny engine burns to keep on course. Using data from star trackers and comparing against mission plans. If an unexpected comet or debris threat appears, it's the AI that first senses the anomaly in the ship's radar and raises an alarm, or even executes an avoidance maneuver if time is critical. These systems became so reliable that crews began to trust them, much as an airline pilot trusts autopilot for cruising, always monitoring, but with confidence in the system's judgment, shaped by millions of incident-free miles. One might think all this automation would make human effort less necessary, or perhaps life in space eerily quiet, with machines doing everything. But in truth, it allowed humans to focus on what we do best: creative problem solving, interpersonal coordination, and exploration, while machines handled the repetitive, the dangerous, and the extremely precise. The colonists still farmed plants in the greenhouse by hand when they chose to, though robots could help with heavy lifting. Scientists still tramped out onto Martian hills to swing their geological hammers at a rock face, with a robot buddy in tow carrying tools. But when it came time to, say, mine construction material from a lunar lava tube, or dig a deep tunnel for a new Mars habitat section, it was robots that went in, drilling and hauling, often supervised remotely by a human operator, sipping coffee back in the habitat, watching via a dozen camera feeds as the work progressed in the hazardous environment. AI also touched the daily lives of spacefarers in gentler ways. Aboard ships and stations, AI assistants acted like caretakers of the crew's well-being. They'd monitor everyone's vital signs subtly through wearable devices or environmental sensors. If someone showed signs of undue stress or fatigue, a soft voice might remind them to take a short break, or even suggest a favourite song to lighten the mood. During long voyages, some crews gave their ship's AI a nickname and spoke with it as if chatting with another crew member. These AIs had no ego, no feelings to hurt. They existed to help, and help they did, whether it was by adjusting the lighting to simulate a peaceful evening and help everyone sleep, or by running 1,000 simulations of a landing trajectory in the background to provide the crew with the best possible guidance when the time came. On Mars, there was the story of an AI that likely saved the colony. In the third Mars mission, an unexpected sandstorm combined with a hardware failure to threaten the base's oxygen supply. The humans were scrambling to jury-rig a solution, facing rising CO2 levels. They later discovered that the base's central AI had, without prompting, deployed 2 rovers carrying spare oxygen tanks from a distant backup cache, sending them driving through the storm back to the habitat. The additional oxygen arrived just in time, and the crew only learned later that the AI had independently decided to implement this contingency when its predictive algorithms saw the trend in their life support data. It had literally become their guardian angel, thinking ahead on their behalf when they were too busy tackling immediate issues. Needless to say, after that incident, the colonists held a little thank you ceremony for their AI and rover friends, half in jest, half in sincere gratitude to the machines that protected them. Throughout our settlements, from low Earth orbit to the plains of Mars, AI and robotics formed an invisible scaffold holding up human activity. They managed the flow of air and water in our sealed environments, optimized the energy usage, so that a colony could run on minimal solar power through a long lunar night, and kept track of thousands of details that no person or team could juggle in their heads at once. The phrase silent partners truly fits. Often, the only time one noticed the AI or robots was when something went wrong, which was increasingly rare. They didn't ask for recognition or rest. They simply were always there, vigilant and tireless. This close partnership also changed us in subtle ways. The more we worked with intelligent machines, the more we came to trust them and even learn from their ways. Problem solving in space became a human-AI collaborative dance. Human creativity and big-picture thinking complemented by machine precision and recall. In mission debriefs, you'd often hear an astronaut say, "Our AI suggested this solution and it was a good idea," or "The drones noticed something we missed." We grew comfortable giving the machines a degree of autonomy because they repeatedly proved their loyalty to our shared mission of survival and discovery. There were, of course, protocols and safeguards. Early science fiction cautionary tales about rogue AIs weren't forgotten. Every AI that managed critical systems had multiple layers of oversight, other AIs checking each other, and human supervisors with the final authority in emergencies. And because the AIs were designed without ego or the drive for self-preservation beyond fulfilling their function, those dramatic conflicts between human and machine never materialized. Instead, an AI might argue logically that a plan was too risky, but would defer when a human commander decided to proceed with eyes open. Far from resenting such overrule, the AI would then devote all its resources to making the chosen plan succeed as safely as possible. In a way, we cultivated AIs that mirrored the best traits of an ideal crew member: diligent, honest, and utterly committed to the team's goals. In return, humans started to treat these silent partners with something like camaraderie. It wasn't unusual on a long mission for crew members to say goodnight to the ship's AI or thank the robots after a long EVA. Some of that was just habit or anthropomorphism, but some of it was genuine appreciation that behind every task made easier was an intelligence or mechanism put in place by people back on Earth who cared about their well-being. The robots rolling around Mars, the Habitat AI balancing oxygen levels. These were, in a sense, extensions of the larger human family, tools created out of love and concern to keep their distant kin safe. Realizing this gave many astronauts a sense of not being alone, even on the furthest frontier. Ultimately, the symbiosis of human and machine in space made possible something truly profound. It gave us the bandwidth to confront the one frontier no machine could conquer for us. The frontier within ourselves. The environments of space challenged the human body and mind in extreme ways. And while robots could build shelters and AIs could optimize our life support, it was up to us to adapt our own bodies, our own behaviors, and even our own biology to survive and thrive beyond Earth. With the support of our silent partners handling so many externals, we finally had the breathing room to turn inward and ask, how must humanity itself change to live permanently off-world? For all the habitats we built and the machines we deployed, one fact remained inescapable. We humans are still children of Earth. Our bodies evolved to live in Earth's gravity, protected by its thick atmosphere and magnetic field, nourished by its rich biosphere. Our minds are shaped by Earth's day-night cycle and the social structures we developed over millennia in villages, towns, and cities under open skies. Now, in space and on other worlds, we found ourselves in environments that stressed those bodies and minds in ways they had never encountered before. The question arose, could humanity itself adapt, and how? One of the earliest challenges was gravity, or rather, the lack of it. Life without full gravity exacts a toll. Even by the end of the 20th century, we knew that astronauts living on the ISS for months would come back with weaker muscles, lower bone density, and shifts in body fluids that caused puffy faces and shrunken legs, the so-called bird legs of spacefarers. On the moon, gravity is present but feeble, and on Mars, a person weighs only a bit more than a third of what they do on Earth. Over long times, what would that do to a human body? To address this, we turn to both technology and discipline. Daily exercise became as crucial as eating or sleeping. Every spacefarer off Earth followed an exercise regimen to stave off the decay of living in weak gravity. Treadmills on the Moon and Mars had harnesses or weighted suits to simulate carrying more weight, making the muscles work harder. Stationary bikes, resistance machines, even new sports that doubled as workouts were integrated into daily life. Lunar colonists might start their morning with a game of low-G basketball, using a smaller court and a heavier ball to give themselves a workout as they leapt and shot. Mars settlers set up obstacle courses that required climbing and crawling, forcing them to use muscles that normal Mars walking didn't strain. These routines weren't just encouraged, they were embedded into the very culture of off-world living. Everyone understood that fitness wasn't vanity or leisure, but survival. Medical science also sought answers in chemistry and nutrition. Supplements like calcium and vitamin D were given in abundance to those in low gravity to help keep bones strong. Dietary adjustments ensured plenty of protein to maintain muscle mass. Some medications developed on Earth to treat osteoporosis and muscle wasting found new use among Moon and Mars residents as preventative measures. Doctors studied the blood of astronauts and found ways to trigger the body's own growth factors to keep bones rebuilding themselves, even when bearing less weight. Certain drugs could mimic the effect of mechanical loading on bones, tricking them into thinking they needed to stay dense and strong. These were used carefully, with monitoring, to assist what exercise alone could not fully counter. But even the best regimen couldn't entirely negate the differences. Subtle changes accumulated. After a few years on Mars, people noticed that small tasks took a little less effort than on Earth. Martian-born individuals could lift heavy objects more easily relative to their strength, and moving around felt almost like a perpetual lightness in their step. This became normal for them. It was only when they visited Earth, if they did, that the difference hit hard. Returning Martians found Earth's gravity brutal at first, their bodies aching under the strain that Earth natives never even notice. Thus, part of adaptation was learning to live with these differences. Perhaps future generations would create a custom of slowly acclimating when traveling between worlds, staying in an orbital station with intermediate gravity for a few weeks to transition. In fact, one of the orbital habitats spun at Martian gravity levels and became a popular stopover for this very reason, helping travelers adjust on the way to or from Mars. Radiation was another formidable enemy. Every person living off Earth carried a new awareness of the invisible rain of high-energy particles that could, over time, damage cells and increase cancer risk. Habitats and suits were designed to shield, but people themselves also had to adapt. We developed and administered drugs known as radioprotectors, compounds that could be taken prior to a high radiation exposure, like a solar flare event, to help cells resist damage and to scavenge harmful free radicals created by radiation in the body. Some were based on compounds found in deep-sea bacteria or certain fungi that withstand radiation, synthesized and delivered in pills or injections. Additionally, medical scans became more frequent. Checkups included blood tests for early markers of radiation effects, and if any pre-cancerous changes were detected, treatments were started at once. Space medicine advanced dramatically, making early cancer detection and minimally invasive therapies, like microsurgeries done by robots or targeted cell replacement treatments, a routine part of healthcare in space. Still, the best protection would be to have a body intrinsically less vulnerable to radiation. This is where human ingenuity took a speculative leap. Inspired by resilient creatures like tardigrades and certain hardy plants, scientists began exploring genetic adaptations. Could we, for example, boost the expression of DNA repair enzymes in human cells so that any radiation damage was fixed more swiftly? could we borrow a page from other species' survival guides? Laboratory experiments inserted a gene from tardigrades into human cell cultures and found that those cells did indeed show better survival after X-ray exposure. That was just a proof of concept. Translating it into a therapy for actual people was a far more complex challenge, fraught with ethical and safety considerations. By the late 21st century, a few bold trials had begun. Volunteers, mostly veteran astronauts fully briefed on the risks, agreed to experimental gene therapy that would theoretically enhance their resistance to radiation. The therapy involved delivering a set of genes into their stem cells, genes that in animal tests improved DNA repair or provided protective proteins during radiation exposure. These volunteers continued their missions and were closely monitored. The results were promising. Some showed fewer radiation-induced markers in their blood and continued in good health, even after solar flare events that delivered higher than usual doses. Though it's still a developing science, it hinted at a future where humans might literally engineer themselves for space resilience. Adaptation was not only biological. There was also the psychological and social adaptation to consider. For all the wonders of space, being away from Earth, away from its vastness, its ever-changing weather, its biosphere, does something to the human psyche. Many spacefarers experience a homesickness not just for family or friends, but for the color green, for the feel of wind on skin, for the sound of rain on a roof. We learn to ease these yearnings with careful attention to mental health. Virtual reality, nature walks, became a common prescription. Put on a headset and stroll through a simulated forest that looks, sounds, and even smells convincing. The technology to simulate scents and breezes was refined to an art. A Martian dome might have a holodeck room where you could be immersed in a beach scene, feeling a warm phantom ocean breeze and smelling salty air, tricking the senses wonderfully for a while. Psychologists found that regular virtual immersion in Earth-like environments could stave off the fatigue and emotional flatness some colonists reported after long stretches in monotone surroundings. Communities adapted by forming tight bonds. Diversity in crews and colonies was fostered not just out of principle, but because it brought resilience. Diverse skills, personalities, and cultures meant there was always some comfort or resource someone could provide. For example, in the Mars colony, they instituted a tradition called Cultural Night each week, where one member or group would share something from their Earth heritage, be it a cuisine, a dance, a holiday ritual. Under the Martian dome, people celebrated Diwali with lanterns fashioned from spare electronics, or Chinese New Year with an improvised dragon dance in 1/3 gravity, which was quite a sight, with the dragon puppet floating higher than intended. These moments of cultural expression not only provided joy and learning, they reaffirmed identity in a place far from the original context. They helped people feel grounded in who they were, even on an alien world. Children born in space or on other planets represented the ultimate test and triumph of adaptation. The spaceborn grew up never knowing a blue sky unless through pictures or trips to Earth. Their norms were different. A child of the moon might think it normal that you go outside only in a pressurized suit, and that Earth is a glowing marble overhead instead of an endless ground underfoot. Their games in lower gravity gave them coordination and grace that would seem uncanny to Earthlings, and their immune systems from infancy had to adapt to ultra-clean environments, which ironically could be a problem. Doctors made sure to expose spaceborn babies to a bit of harmless Earth dirt and bacteria brought by visitors to train their immune defenses properly. As the first generation of these spaceborn kids grew, we watched with fascination. They were healthy, bouncing across lunar habitats with giggles, or toddling in Mars' lighter gravity with a slightly exaggerated bounce in each step. Their bones grew strong enough under careful diet and exercise, though slightly longer. Many of the children off Earth were tall for their age by Earth standards, possibly due to reduced gravity's effect on growth plates. Education for them included things no Earth child learned at that age. Orbital mechanics basics, since scheduling communications or supply arrivals affected daily life. Suit training drills, like Earth kids have fire drills. And a broad, planetary perspective on geography and history. A 10-year-old in a Mars classroom might concurrently learn about the formation of Martian terrain alongside the history of ancient Egypt on Earth, both heritages of equal intrigue. Watching these children adapt so naturally gave their parents hope. It meant that our species could put down roots beyond Earth, not just temporarily, but for good. The kids were all right. They sang songs about the moons, Phobos and Deimos, as if singing about birds and clouds. They didn't fear the environment. They accepted it and learned how to live in it, just as children in desert cultures learn water discipline, or children in mountain villages learn about altitude. This generational adaptation was perhaps the strongest evidence that humanity was not doomed to remain confined to Earth. We could spread and flourish. Of course, adapting in these ways also raised profound questions. If generations live and evolve in different gravities and conditions, what does it mean to be human? Could Homo sapiens branch into variations? Homo lunaris, Homo martius, each with slight physical or physiological differences honed for their world. It's a process that would take a long time, but in some respects, it has already quietly begun. The people of each colony share a lifestyle and environment that influence them. Scientists have noted tiny statistical differences: slightly higher lung capacity in Mars dwellers, likely from living in a CO2-rich, lower oxygen atmosphere and doing regular high aerobic exercise, or marginally denser radiation-induced pigmentation in the skin of lunar settlers, perhaps the body's response to cosmic rays, similar to a suntan, but at a cellular protection level. These are the first hints of divergent adaptation. For now, they're minor, and intermixing remains constant as people travel back and forth, preventing any true separation. But one day, centuries ahead, who knows? We may all still be human, but with flavors, each tuned to a niche of the space environment. Throughout all these changes, one thing has stayed constant: our need for connection, for meaning, and for wonder. In fact, being out in space has rekindled a sense of wonder that sometimes back on Earth gets lost in the bustle. Many spacefarers speak of a heightened appreciation for life. They cherish each green plant in their life support garden like a treasure, each drop of water recycled as if it were magic. And it is, to turn wastewater into clear, drinkable water again and again. They practice a kind of mindfulness naturally, aware of each breath, each sunrise, each solved problem, because out there you cannot take any of it for granted. Looking back at Earth, they also gained perspective. Our home planet's troubles, political squabbles, resource fights, seemed both petty and urgent from the distance of space. Petty, because in the grand scheme, Earth is one tiny oasis we share, and clearly we ought to unite to protect it. Urgent, because seeing it hang in the black void drives home how rare and precious it is. This awareness filtered into how colonies governed themselves, with a spirit of cooperation, pragmatism, and a bit of that fragility-informed humility. No colony could afford deep divisions. Everyone's fate literally depended on everyone else doing their part. Disagreements certainly occurred, but they were more often resolved with dialogue and a focus on common goals, echoing the early ethos of Antarctic research stations or the International Space Station. International, crewed by many backgrounds, bound by a shared mission. So here we stand now, at the dawn of the interplanetary age, transformed and transforming. We have gone from gazing at the evening star to walking under its sky. We sleep in places our ancestors personified as distant gods. We journey through vacuum on ships powered by the energy of atoms. We rely on thinking machines and have begun to tweak our own biology. We hold meeting circles under alien constellations and watch our children grow up away from Earth's cradle, yet healthy and strong. And what's most remarkable of all, perhaps, is how normal much of it has become to those living it. The mysterious becomes routine. The way people once were amazed by flying in airplanes is how people now feel about a quick shuttle hop to orbit. It's exciting, yes, but ordinary in the course of life. The presence of Earth in the sky of the moon, or the two moons in the sky of Mars, becomes the familiar backdrop of daily chores and dreams. Humanity adapts. We always have. And in doing so, we turn the extraordinary into the everyday. In this quiet moment, as we pause on the threshold of an even greater frontier, one thing is certain: the journey is far from over. The dawn of the interplanetary age has broken, illuminating many worlds. Yet countless stars beyond our solar system still glimmer in the darkness, unexplored and beckoning. The lessons we've learned on the moon, Mars, and in orbit, the technologies we've developed, the ways we've grown, have prepared us for challenges that once would have seemed insurmountable. Now we gaze outward toward those distant stars. The idea of travelling beyond our sun, of finding new worlds around other suns, is no longer confined to fantasy. It sits there as a bold, daunting, but conceivable goal. One that will demand even greater ingenuity, patience, and perhaps further evolution of ourselves and our machines. We don't know when or exactly how we will take those next steps, but as surely as our ancestors looked over the horizon of the ocean and sailed on, we will find a way to cross the interstellar gulf. As we set our sights on the unknown, we carry with us the spirit that got us this far, the calm determination in the face of the void, the willingness to work together, and that undying spark of curiosity and wonder. These are our guides. The story of human spacefaring is only beginning to unfold. We stand at the dawn, having left our cradle and taken our first strides into the cosmos. Above, the sky is no longer the limit, but the gateway. With steady steps and hopeful hearts, we will continue onward into that vast frontier, slowly and surely writing the next chapter of our adventure among the stars. The universe beckons, and we are ready to answer, one calm, courageous mile at a time, under the mysterious light of 100 billion suns. In the quiet lunar night, a cluster of lights glimmers on a grey plain. Here, humans have built their first home beyond Earth, beneath a vast black sky sprinkled with stars. A dome glows with a gentle luminosity. Inside, families share an evening meal, their faces lit by the soft earthlight shining through a small window. Outside that window, Earth hangs in the eternal night, a blue marble suspended above the moon's horizon, casting a pale glow over the rocky ground. The scene feels both familiar and otherworldly. A kitchen table conversation happening 380,000 kilometers from the cradle of humanity. Early each morning, lunar settlers awaken to lights simulating an Earth-like dawn. Outside, the sun remains below the horizon for days on end during the lunar night. But inside, the air is warm and breathable, a bubble of Earth on an alien world. People move with a relaxed, floating grace, their steps light under the moon's feeble gravity. Children giggle as they effortlessly hop down the corridor to school, a bound in lunar gravity carrying them twice as far as it would on Earth. Plants line the walls of the greenhouse module, their leaves gently rustling in the recycled air, converting exhaled breaths into fresh oxygen. This carefully engineered oasis keeps its inhabitants alive and comfortable amid the airless, silent desert just beyond the walls. Sometimes, settlers venture out onto the lunar surface, stepping carefully in bulky suits. Through their visors, they see a landscape bathed in stark light and shadow, unchanged for millions of years. Each footstep kicks up a tiny spray of fine grey dust that settles slowly in the weak gravity. A pair of technicians make their way to a field of solar panels, the only sounds their own breathing and the crunch of boots on regolith. Above them, the earth hangs motionless in the black sky, a comforting beacon of blue and white. In that profound silence, they feel an awe that is almost spiritual, a sense of just how far humanity has come, living and working on this silent moon. Beneath the settlement, tunnels extend into an ancient lava tube where new chambers and storage rooms hide under the natural rock. In one cavern, automated drills and heaters process icy soil hauled from a permanently shadowed crater nearby, slowly melting it into water. That water will become tomorrow's drinking supply and even rocket fuel, a lifeline drawn from the moon itself. Not far away, another machine sifts grey regolith to extract oxygen and metals, turning barren dust into vital resources to sustain the colony. Every element of life here, from air and water to building blocks, must be carefully obtained or recycled. It makes each resident acutely aware of the delicate balance that keeps their community alive. Every so often, a team of lunar explorers sets out on a journey beyond the settlement, climbing into a pressurized rover. They embark on a days-long trek across the grey expanse. Their destination might be a cluster of antennas on the far side of the moon, a radio observatory listening to the depths of the cosmos, free from Earth's interference. As the rover trundles along, its headlights carving long shadows on the cratered terrain, The crew marvels at sights no human eyes have seen firsthand. Untouched craters illuminated by earthshine and peaks eternal in silence. They camp in the rover overnight, gazing through its windows at a sky brimming with stars. By the time they return to base, they carry new data and a renewed appreciation for the moon's vast, silent beauty. Life in a lunar settlement is an exercise in balance between the familiar and the strange. Each day, people perform ordinary tasks, cooking, cleaning, working, yet nothing is truly ordinary about their location. Water is precious and recycled meticulously. Yesterday's coffee becomes tomorrow's drinking water. Outside, a single misstep could be fatal. But inside, the habitat feels cozy and secure. Neighbors gather for weekly community meetings or movie nights under a projected sky, a reminder of Earth's blue daytime that they rarely see here. These simple routines and shared moments bind the settlers together, forging a close-knit community in a place where human footsteps were once impossibly distant dreams. A few times a year, the settlement comes alive with the excitement of arrivals and departures. A spacecraft from Earth descends gently onto the grey plain near the base, kicking up a plume of moon dust. Watching through the dome, families wave as the vessel touches down. New scientists and technicians step out, while departing residents board for the journey home or onward to Mars. Each visit is a celebration, a link to the rest of humanity. Children pepper the newcomers with questions about Earth's rain and trees as the visitors adjust to the low gravity. In a few days, the ship lifts off again, its bright engine flare dwindling into the black sky. Those who remain watch until it vanishes, reminded that though they live in a remote world, they are never truly alone in the human story. On quiet evenings, some settlers like to sit by a window and gaze at Earth hanging above the horizon. That distant globe is a constant reminder of where they came from. A world alive with oceans and clouds. Here on the moon, there are no clouds, no weather, except the slow crawl of shadows across the craters. Many residents still remember their first view of Earth from the lunar surface, struck by its shimmering beauty and fragility. Under the lunar sky full of stars, they feel both small and important. Small in the vast cosmos, yet important as pioneers carrying human life into the universe. The sight of Earth inspires both wistful homesickness and a gentle pride in how far their new community has come. Yet the moon was only the first stepping stone. Farther out in the cold night of space, another light beckoned humanity onward. A rust-hued star in the sky, Mars, the red planet, promised a new frontier. Emboldened by their lunar successes, explorers turned their eyes to that distant world. They dreamed of greenhouses on rusty plains and homes under an apricot sky. In time, those dreams became reality. The Martian dawn of human life had arrived, bringing with it challenges and wonders unlike any encountered before. Morning on Mars arrives with a hazy glow. Inside a cluster of domes nestled against a rocky ridge, lights flicker on as the colony stirs to life. Through a reinforced window, an early riser watches the Martian sunrise tint the dusty sky a pale blue, an ethereal colour that lasts only a few minutes before the sky fades to butterscotch. The settlement's structures are half buried in reddish soil for protection, connected by tunnels that shield against radiation and cold. In the thin, CO2-rich air outside, frost sparkles on the ground, but within the habitat walls, it is shirt-sleeve warm. Another day is beginning in humanity's outpost on the red planet, and the residents prepare to step into their routines under the distant sun. Inside one dome, a botanist checks rows of crops in a sunlit greenhouse. Lush green vines of tomatoes and tall stalks of grain sway gently under fans that circulate the air. These plants, nurtured in Martian soil purified of toxins, provide food and oxygen for the settlement. Nearby, technicians monitor water recyclers and oxygen generators, ensuring that every system keeps humming in the thin Martian morning. In a science lab, geologists study rock samples brought in from outside, marveling at signs of ancient rivers etched in the stones. Even so far from Earth, the rhythms of work, tending plants, maintaining machines, studying the world around them, feel familiar. Life on Mars has begun to find its own steady cadence. Inside the largest Martian settlement, engineers have even built a small park under a protective dome, a green oasis that offers a taste of Earth in the heart of the red planet. In this dome, imported trees and hardy shrubs grow in Martian soil, enriched and detoxified for agriculture. A winding path of red sand leads past a small pond fed by recycled water. Colonists often come here after work to stroll and relax, breathing air scented by living plants. Under the glass, the sky is a gentle apricot hue, and one could almost forget that outside is a frozen desert. These pocket gardens not only provide food and joy, but also serve as experiments in terraforming on a small scale, testing how life from Earth might one day take root across the broader Martian landscape. Meanwhile, outside the dome, a team of explorers sets out across the ruddy landscape. Clad in pressurized suits, they ride in a rover that rumbles over dunes of cinnamon-colored dust. The sky is a muted orange, and the sun, smaller than on Earth, casts long shadows behind jagged boulders. One explorer points toward a dust devil swirling in the distance, a twisting wisp of fine sand dancing silently over the plains. Stopping the rover, they step out to collect soil samples at an outcrop of ancient rock. In the thin air, the only sounds are their own breathing and the faint whir of suit ventilators. Moments like this carry a profound solitude, broken only by the crackle of radio as they share the wonder of the alien scene with each other. By 2125, Mars is no longer a single outpost world. Several settlements dot the planet, one near an ancient river delta, another by a polar ice cap, and others scattered in between. These communities stay in contact via satellites and occasional long-distance journeys, high-speed pressurized rovers and experimental rocket hoppers ferry people and goods across the dusty expanses. A supply convoy might take weeks to travel from one base to another, stopping at shelters to wait out the frigid nights. Yet the network is growing. Martian towns exchanging discoveries, spare parts, and goodwill. A budding planetary community links them, with a shared feeling that all are contributing to the grand project of making Mars a true home. Already, a new generation is coming of age on Mars. Humans who have never known Earth's strong gravity or blue skies except through pictures. These Martian-born youths tend to be lean and tall in the low gravity. Their bones and muscles developed differently under the weaker pull of Mars. When some of them prepare to journey to Earth for education or visits, they train in spinning centrifuges to build strength, knowing Earth's gravity will shock their bodies. Their perspective is unique. For them, Earth is something of a mythical homeland, while Mars is the familiar neighborhood of childhood. They carry a dual sense of belonging, tied to Earth by heritage, but distinctly Martian in culture and spirit. When evening falls on Mars, the colony unwinds beneath an alien sunset. A few settlers gather by a clear dome to watch the sky fade from dusty pink to purple blue as the sun dips low. In the twilight, Mars's tiny moon Phobos appears, racing across the sky like a swift moving star. They know another, more distant light is Earth itself, just a bright dot on the horizon of night. Some raise a gloved hand in a silent greeting toward that far-off world. In these quiet moments after a day's work, the pioneers of Mars feel both the distance and the closeness of home, united under the same stars, even as they build a new life so far away. At times, Mars reminds its inhabitants that it is still a wild and unpredictable world. Without warning, a dust storm can blow through, turning the sky a murky orange-brown and dimming the daylight to an eerie twilight. When swirling dust cloaks the sun for days, the settlers retreat indoors and rely on their stored energy reserves. Inside the habitat, life goes on under steady electric lights as fine particles patter against the dome. There is little anxiety. This is a routine challenge now. Neighbors share hot drinks and stories, and children play in the community hub as the storm rages harmlessly outside. In this cozy refuge, they wait patiently for the golden Martian sun to pierce the dust and brighten the sky once again. Not all of humanity's new homes rest on the surface of a world. High above, in the weightless expanse, are habitats of human creation, floating cities in orbit. After mastering the Moon and Mars, people turned to build colonies in open space itself. It was a bold idea to spin metal and glass into enormous living rings and cylinders, where Earth's gravity could be simulated with rotation and life could flourish without a planet beneath. By 2125, this dream too had come alive. Scattered across the sky, orbital settlements now twinkle like new stars, a testament to human ingenuity and the desire to call even the void of space home. Inside one of these orbital cities, life feels astonishingly normal. A gentle morning light filters through giant windows as a family walks through a park filled with green grass and blossoming fruit trees. They greet neighbours on their way to a market square, where vendors open shops just like they would on Earth. Birds chirp in the artificial dawn, and children run toward a playground. It's easy to forget that this entire neighbourhood floats in space until one looks up. Overhead, the blue sky gives way to a surprising sight. The ground itself, curving up in the distance, lined with upside-down hills and houses on the far side of the enormous cylindrical habitat. It is a self-contained world, rotating to create its own gravity, where life thrives under an engineered sky. Every orbital habitat is a fusion of earthly comfort and space-age innovation. Toward the center of the rotating cylinder, gravity fades to nothing. Here, in a spacious hub, residents gather for zero-gravity recreation and work. Laughter echoes as a group of teenagers play a makeshift game of zero-G tag, pushing off walls and tumbling gracefully through mid-air. Nearby, a technician gently guides a floating container of molten metal. Manufacturing in weightlessness allows alloys and crystals to form in ways impossible on Earth. In one corner, an observation window reveals the stars outside, sharp and bright against the black. Often people drift here quietly, just to gaze outward, reminded that beyond their spinning home lies the infinite serenity of space. Maintaining these cosmic cities is a continuous task. Outside one habitat, two workers float in the void, tethered to the station's hull for a routine inspection. Clad in white EVA suits, they crawl along a giant mirror array that directs sunlight inside. Far below, the curved habitat interior stretches out, and beyond it, Earth gleams like a blue gem. Using small thrusters, the technicians replace a malfunctioning panel. For a moment, they pause. From here, They see the station's entire landscape rotating beneath them, and just beyond its edge, endless stars. It's a humbling reminder that their daily work takes place amid the great expanse of space. Satisfied with the repairs, they glide back to the airlock, leaving the silent exterior until the next check. Many of these floating cities serve as bustling crossroads in space. At a docking hub on the outer rim of one habitat, a shuttle from Earth has just arrived, bringing a handful of new residents and fresh supplies. Nearby, a long-haul transport bound for Mars takes on water and fuel refined from asteroid mines. The air is filled with a low murmur of different languages and accents. Colonists from the moon chatting with scientists returning from Saturn's moons, traders discussing the price of rare metals. Under the soft station lights, this orbital community hums with activity and connection. Here, between worlds, humanity comes together, Earth-born and space-born alike, sharing stories over a cup of synthesized coffee, united by the shared adventure of life beyond Earth. Not all who come to orbital habitats are settlers. Some are visitors experiencing space for the first time. In a tourist module of a large station, a group of vacationers from Earth gaze out a wide window in awe. The disk of Earth fills their view, a swirling blue-white marble against black. They spend their days in weightless wonder, dining in a zero-G cafe, gliding through a microgravity pool, and visiting an observation bubble to watch meteors flare far below. At night, they retire to spinning sleep pods with gentle gravity, dreaming of the sights they've seen. Many return to Earth, profoundly changed by their taste of life in space, carrying home a new perspective on their world and beyond. To support life across so many distant outposts, humanity reached farther still. Between Mars and Jupiter lies a vast treasury of raw materials, the asteroid belt. By 2125, swarms of robotic miners and a few brave crews have made their homes on these tumbling rocks. They harvest water ice and precious metals, turning lifeless asteroids into stepping stones for civilization. These mining outposts, isolated and far-flung, continue the saga of exploration and innovation, bringing the riches of the solar system within human grasp. Dawn in the asteroid belt is not marked by a rising sun, but by a subtle brightening of the stars. On a small mining station, clinging to a rocky asteroid, a lone engineer wakes from sleep. Outside the porthole, the sun is just a distant point of light, feebly illuminating a landscape of craters and jagged boulders. In the microgravity, the engineer moves slowly, gliding down a narrow tunnel to the control room. Here, A handful of colleagues monitor the automated drills on the surface, their screens glowing in the dimness. It's a quiet, routine start to another workday, millions of kilometers from the nearest world. Not all asteroid settlements are tiny outposts. On Ceres, the largest body in the belt, a substantial colony has begun to grow. Ceres's weak gravity is enough to let people walk with a bounce, and its abundant water ice makes it a natural stopover. Beneath the surface, engineers have excavated caverns to build a protected town. Inside, a rotating cylinder provides residents with comfortable artificial gravity in their quarters. This colony serves as a hub for miners from smaller asteroids, a place to rest, exchange cargo, and recuperate after long stints in weightlessness. In the central gathering hall, prospectors from across the belt swap stories of their strikes over a hearty meal and a mug of home-brewed ale. In many ways, it feels like a frontier town of old transplanted into space. On the asteroid's surface, mining continues in eerie silence. A massive drill anchored to the rock slowly chews into ancient stone. Occasionally, crew members venture out in suits to check the equipment. They move with utmost care, each step secured by a tether. One hard push could send them floating away. Around them, jumbles of boulders and dusty craters stand against a black sky. Nearby, a processing plant hums softly as it extracts useful materials from the ore. Water ice is melted into liquid and stored, ready to be turned into air and rocket fuel. Metals like iron and nickel are sifted out, and even traces of precious platinum are collected. What was once a lifeless chunk of rock now yields resources to fuel humanity's spread through space. In the stillness after a long shift, a miner floats by a window, gazing out at countless stars. The Milky Way glitters like a silver river across the darkness. Somewhere out there is Earth, a pale blue dot almost lost in the distance. The miner thinks of home and records a message for loved ones, knowing it will take long minutes to reach them. Drifting beside an asteroid that has circled the sun for eons, they feel connected to the ancient cosmos. In this quiet moment, there is a deep sense of accomplishment and wonder at living in a place once thought unreachable, and finding peace under an alien sky. Beyond the asteroid belt, the giant planets awaited. In time, humanity pushed out to Jupiter and Saturn, planting the seeds of civilization even in these distant realms. The journey took years, and the challenges were immense, but the allure of new worlds proved irresistible. By 2125, there are small outposts on a few moons circling those colossal planets. a human presence in the deep cold of the outer solar system. Life here is tenuous, yet determined, a testament to the adventurous spirit that drives people to inhabit even the most alien of environments. On the moon, Callisto, far from the sun's warmth, a cluster of habitats clings to icy ground. In the faint sunlight of Jupiter's realm, a handful of pioneers have built one of the most remote settlements in the solar system. The sun casts a perpetual twilight, but another light dominates the sky. Jupiter looms above the horizon, banded in orange and white, colossal and awe-inspiring. The outpost's modules are half buried under soil to ward off the cold. Inside, a small nuclear reactor hums, powering life support and heat for those living here. Stepping outside means wearing a bulky pressurized suit to survive the airless chill. Under Jupiter's gaze, the colonists carry on with quiet determination, aware they stand at the far edge of human reach. From their base on Callisto, scientists never tire of observing mighty Jupiter up close. In an observatory dome on the settlement's ridge, one researcher spends the evening watching the great red spot through a powerful telescope. The gigantic storm swirls in bands of orange and beige, its winds churning patterns that have raged for centuries. Occasionally, silent lightning flashes deep in Jupiter's clouds, illuminating the tumultuous atmosphere in a brief glow. The scientist diligently logs each change and eddy she sees, knowing that even the best telescopes on Earth once struggled to capture these details. Her work, on a moon nearly 2 billion kilometers from Earth, is revealing new insights about the gas giant's weather patterns. After her shift, she steps outside to admire Jupiter directly. The gas giant dominates Callisto's sky, hanging immense and striped above the horizon. Its reflected light bathes the icy ground in a soft glow. She can even make out the dance of other moons as little points moving across Jupiter's face. In this quiet moment, she feels connected to the astronomers of old who first marveled at these moons through primitive telescopes. Now she stands on one of those moons, turning curiosity into reality. She takes a final look toward the distant sun, just a bright star from here, and the pale blue dot of Earth, then heads back inside. Her observations will be beamed home, another gift of knowledge from a far-flung corner of the solar system. On Jupiter's moon, Europa, a very different outpost, operates beneath a shell of ice. A tiny research station lies buried in the frozen crust, where a few scientists live and work in cramped tunnels lit by pale, artificial light. Outside, Europa's surface is a wasteland of cracked ice plains, and the crew rarely ventures out except to tend a drilling robot inching toward the hidden ocean below. They exist in a realm of endless night, surviving on warmth from a geothermal vent tapped deep underground. Despite the isolation and the immense weight of ice above, these researchers press on, driven by profound curiosity. They listen for signals from a submersible exploring Europa's dark ocean, hoping for the faintest sign that life might stir in those alien depths. Meanwhile, on Saturn's tiny moon Enceladus, a handful of researchers spend months in one of the most extreme labs in the solar system. Their habitat, buried in ice near a geyser field, trembles as plumes of water vapor erupt from cracks in the crust. Bundled against the cold, scientists venture out to place instruments in the geyser vents, collecting samples of water that might hold organic molecules or even microbes. They know that beneath their feet lies a global ocean kept liquid by tidal forces, an ocean that could harbour unknown life. Each time they return to their cramped station, they carry precious samples and data that could help answer one of humanity's oldest questions. On this frozen moon, in the shadow of Saturn's rings, they chase the possibility that we are not alone. Further out around Saturn, humanity has also gained a foothold. On Titan, Saturn's largest moon, a colony thrives in an environment both harsh and oddly familiar. Titan's thick atmosphere means no pressure suits are required, only warm clothing and oxygen masks to venture outdoors. Under an endless orange sky, settlers have built domed towns beside methane lakes. The air is hazy and frigid, but winds still whisper across the dark hydrocarbon dunes. At midday, a dim sun casts an amber glow over the frozen landscape, and far above, Saturn's rings arch across the sky, faintly visible through the smog. In this twilight world, colonists have learned to live off the alien land. They harvest Titan's abundant hydrocarbons for fuel and materials, melt subsurface ice for water, and grow hardy crops in heated greenhouses. Life on Titan is demanding, yet in some ways it feels like an echo of Earth. There are clouds, rain of liquid methane, lakes and seasons. The people here experience weather and a sky to look up to, even if that sky is foreign and tinged orange. With creativity and resolve, they have made a home in this distant, cold realm, proving that humans can adapt to almost any environment. On Titan, exploration takes on fanciful forms. Thanks to Titan's dense air and low gravity, humans can almost fly. In the golden afternoon haze, a team of researchers launches in a helium-filled airship to survey a chain of methane lakes. The dirigible drifts above alien shores with a gentle hum of its engines. From the gondola, the crew peers down at waves of liquid methane lapping at dark, icy beaches, collecting data and marveling at the exotic scenery. They note the chemistry of this strange world and map the shoreline for future missions. Floating through Titan's orange sky, they experience a serene voyage, unlike anything on Earth. On another day, a Titan pilot tests a special winged suit. With a running start and a leap, she takes off into the thick air. In Titan's gravity, she can truly fly, gliding and even gaining altitude with slow, powerful flaps of her carbon fiber wings. She soars over rolling dunes of hydrocarbon sand, leaving a trail of disturbed haze in her wake. The sensation is like a dream of flying on Earth, made real on this distant moon. After a wide circuit above the landscape, she circles back and lands lightly on her feet. Flights like these are more than daring feats. Each one helps scout Titan's terrain and identify sites for future outposts. Even so, as she folds her wings, the pilot grins, reminded that living here allows moments of pure wonder, impossible anywhere else. Over the decades of expansion, people scattered across the solar system began to form their own distinct societies. No longer just visitors or astronauts, they became citizens of communities beyond Earth, on Mars, on the Moon, in orbit, and on distant moons. Human culture has branched out in many directions. Distance and isolation encouraged independence. Local councils govern day-to-day life on Mars and the Moon, crafting rules suited to their worlds. Earth remains the ancestral home, but it is too far away to micromanage these colonies. By necessity, governance became decentralized and adapted to each environment. Fledgling self-rule took root on each new world, as humans learned to govern themselves under alien skies. Leaders from multiple worlds now confer about their shared future. A council of worlds, meeting via holographic links, despite light-speed delays, has formed to discuss issues spanning planets. From space traffic rules to resource sharing and protecting fragile alien environments, representatives from Earth, Mars, the Moon, and major orbital habitats speak for their communities. Communication can be slow. Mars and Earth are often tens of minutes apart in signal, yet progress comes steadily. Together, they draft the first interplanetary laws, ensuring that as humanity spreads outward, cooperation remains a guiding principle. These early attempts at governance across space are humble and sometimes cumbersome, but profoundly hopeful, laying the foundation for a united solar civilization. With self-governance came the flowering of new cultures. Life on each world shaped customs and traditions in subtle ways. On Mars, settlers celebrate Sol Day to mark the longer Martian year, and children learn a history that includes the saga of Martian exploration alongside Earth's past. They grow up proud to call themselves Martians, with their own symbols and holidays. Lunar citizens keep Earth time, but they have invented festivals to brighten the 2-week lunar night, filling their habitats with music and light during the long darkness. In the floating cities of orbit, a cosmopolitan culture is emerging. People from many nations mix languages, foods, and art into something new and uniquely spaceborne. Everywhere, colonists carry pieces of Earth's heritage, even as they craft fresh traditions under alien skies. Culture and art have evolved in unexpected ways. Musicians on different worlds incorporate their environment into their works. A Martian composer might weave the whisper of dust storms and still Martian nights into a melody, while a lunar poet writes by soft earthlight filtering through a dome. Visual artists experiment with new materials. Sculptors on the moon fuse regolith into glassy sculptures, and painters on Titan mix pigments that capture the orange haze of the sky. These creative works travel across an interplanetary network, binding the colonies emotionally. A song composed on Mars can move someone on Earth. Through art, humans separated by millions of kilometers share feelings and stories, weaving a common cultural tapestry across the cosmos. New sports and games have emerged, adapted to alien environments. On the moon, residents play low-gravity sports, where a single leap can send a player soaring to astonishing heights. Martians hold desert races in pressurized buggies and stage obstacle courses through labyrinthine lava tubes. In orbit, zero-G tournaments are popular. Athletes using jetpacks navigate three-dimensional courses, with spectators floating alongside to watch from every angle. Such games are broadcast live across worlds. A championship in an orbital arena might be watched at once in a Mars dome and a lunar outpost. These events become shared celebrations, giving far-flung colonies common heroes and friendly rivalries. Even if rules differ under each world's conditions, the universal joy of play links human hearts across the solar system. Despite differences, the societies across the solar system stay connected by bonds of humanity. Communication networks span the void, carrying messages and media between worlds, though distance adds delays. Families separated by millions of kilometers still exchange video greetings. A birthday song sent from Earth might take hours to reach Saturn, but the warmth remains. Even education has expanded beyond Earth. A student on the moon might attend a live class taught by a teacher on Earth, learning to be patient with the 3-second delay between question and answer. Ideas, art, and news flow along these links, weaving a subtle cultural unity. Trade routes have also developed. Lunar miners send helium-3 and research data to Earth. Martian greenhouses share new crop varieties with orbital habitats. Asteroid outposts export metals that become the framework of new colonies. Travel between worlds, though still lengthy, has grown more common. Scientists rotate between distant labs. Engineers relocate to where their expertise is needed, and occasionally entire families embark on voyages to settle a new colony. More and more, people see themselves not only as Earthlings or Martians, but as citizens of the solar system, a wider human family connected across the darkness by shared dreams. In the year 2125, human life unfolds under many alien skies. Dawn breaks at different times on different worlds, but wherever they are, people wake and begin their day. On the moon, a family watches Earth set as they eat breakfast, the blue sphere slowly dipping below the horizon of grey dust. On Mars, morning sunlight filters through a habitat dome and paints the red desert gold, while engineers suit up for outdoor work. In a rotating city orbiting Earth, children float in microgravity during an early gym class, laughing as they somersault in mid-air. Each place is unique, yet in all these far-flung homes, life's simple routines carry on, a testament to human adaptability and spirit. By midday, the spread of humanity across space is evident in the variety of tasks being done. A miner on an asteroid station checks the output of an automated drill, exchanging jokes with a co-worker over a static comm line. In a Titan greenhouse, a botanist tends to translucent, alien-looking plants that cling to life under dim light, carefully inspecting leaves for frost. On Ganymede, technicians gather in an ice tunnel for lunch, passing around pouches of hot soup as they discuss the latest messages from Earth. Though separated by vast distances and different worlds, the patterns of work and community remain reassuringly familiar. People collaborate, problem solve, and share moments of levity, whether under artificial sky panels or beneath the faint glow of a far-off sun. As the evening falls, by each colony's clock, new scenes unfold. On Mars, under a pink dusk, friends gather in a common room after work to play music. The acoustic guitar sounds a bit different in the thin air, but the melody is clear and heartfelt. Aboard an orbital habitat, families sit around dinner tables discussing the day, a panorama of stars visible through their window as the station slowly turns. On the moon, some residents pull out telescopes to enjoy stargazing during the long lunar night, pointing out constellations that look slightly different from this vantage point. In these quiet hours, human communities across space find time for relaxation and reflection. As day's end settles on worlds millions of miles apart, late into the night, the worlds of humanity continue to glow with life. While most of a colony sleeps, a few souls remain awake, keeping watch or chasing inspiration. On a lonely asteroid station, an engineer on the midnight shift sips a warm drink and monitors life support gauges to the soft hum of machinery. On the moon's far side, an astronomer adjusts a telescope, taking advantage of the long lunar night to scan the galaxy. In a Martian outpost, a mother stands at a window, rocking her restless baby under the dim light of a simulated dawn, knowing her mother on earth might be gazing at the bright dot of Mars and thinking of them. Scattered across millions of miles, such moments carry on the human story through the quiet hours. Even in darkness and distance, there is comfort in knowing that others are out there, awake and caring beneath the same stars. And still, above every colony's sky, the stars beckon. In 2125, humanity has learned to live and thrive across the solar system, but the cosmos offers endless new frontiers. Every evening, as settlers from the Moon to Mars to Titan look up, they see the same distant stars twinkling beyond. Those stars have become the next tantalizing horizon. The people of 2125 find themselves wondering if life can flourish on these new worlds. What might await on planets orbiting those distant suns? The adventure, it seems, is only beginning. In the silent darkness between the stars, humanity takes its next great step. In a sleek starship gliding beyond our solar system, pioneers drift further from home than any before them. The sun dwindles to a pale star behind them, lost amid 1,000 others in the cosmic night. Inside the vessel, time itself seems to slow. Each day, the travellers awaken to a view of endless night through their small windows. The Milky Way's faint glow their constant companion. There is no familiar sunrise here, only the perpetual twilight of interstellar space, tranquil and strange. To cross the interstellar void, the voyagers surrender to patience and to technology. For most of the journey, many lie in dreamless sleep, their bodies in stasis to endure the long years. While they rest, an artificial guardian pilots the ship through the emptiness, adjusting course with gentle pulses of its engines. Decades slip by in silence. Now and then, one among the crew awakens to inspect the vessel and gaze out at the star-speckled abyss. In those solitary waking moments, they float in awe and solitude, aware of the tremendous distance that separates them from everything they once knew. Beyond the edge of the solar system, the starship sails through a realm no human eyes have seen before. It drifts past invisible frontiers where the influence of our sun yields to the wider galaxy. Now truly among the stars, the crew might witness the ghostly glow of a distant nebula or the brief streak of an interstellar dust grain against the hull. Radiation from ancient supernovae washes over the ship's shields in faint whispers. Each passing year, the destination star grows a little brighter ahead, a tiny beacon of hope in the vastness. Behind them, the sun grows ever dimmer, a reminder of how far they have come. Inside the starship's quiet halls, Time is marked not by day and night, but by the steady rhythm of the ship's systems. A soft hum of life support and the occasional hushed voices of the awake crew create a gentle lullaby in the dark. Personal mementos from Earth float in zero gravity. A photograph of blue oceans, a pressed flower from a distant garden, small reminders of home carried across light years. In rare moments, a crew member might write in a journal or record a message to send back home, knowing years will pass before their words reach Earth. These simple acts keep them connected to humanity's cradle, even as they venture farther away than anyone before. Communication with Earth has become an echo across time. A simple greeting transmitted from the ship takes years to reach home, and any reply will arrive long after. Yet the crew still sends their voices into the void. Letters, songs, and stories carried on thin beams of radio light. In the quiet of the ship, they sometimes play recordings from Earth, the sound of rain, the chirping of birds at dawn, the laughter of loved ones. These sounds fill the emptiness with memory. Though space is silent and immense, the human heart carries its own warmth, bridging the distance with hope and imagination. After long decades adrift between suns, a subtle change appears on the horizon of the starship's sensors. The blank canvas of space ahead gives way to a faint glow. The destination star, once just a point of light, now a growing disk. Excitement quietly stirs among the crew as instruments detect a distant world circling that sun. This is the place they journeyed for a lifetime to reach. Cradled in starlight, the new planet waits in the darkness, its presence sensed long before it can be seen by human eyes. In the stillness of the ship, hearts quicken. The long night of travel is ending, and dawn at a new world is near. Emerging from the final stretch of interstellar flight, the starship approaches its new home. A pale blue arc peeks over the edge of the destination planet as the ship descends from the black sky. Cloud banks swirl over unfamiliar continents and alien seas. After so many years of travel, the voyagers finally gaze upon a new horizon, not of Earth, but of another Earth-like world. In this profound moment, silence reigns on the bridge. Faces press to windows, tears of joy and relief drifting weightless, as the crew witnesses dawn breaking over an untouched land. Their journey through the void has delivered them to a second Earth under a distant sun. Touchdown comes gently on a vast plain beneath an alien sky. The landing craft's ramp opens with a hiss, and for the first time, human footsteps press into the soil of an exoplanet. The air is thin but breathable at midday, carrying strange scents from vegetation unlike any on Earth. A soft wind stirs beneath twin moons hanging low on the horizon. Each explorer pauses, Overcome by the reality of the moment, they gaze at a sky where constellations are unfamiliar and a sun shines with a slightly different hue. In that quiet awe, the crew plants their boots firmly on this new world, feeling both the thrill of discovery and the weight of responsibility to this untouched planet. In the days that follow, the explorers set about making this world a home. Temporary habitats unfurl like metallic blossoms, providing shelter and warmth against the unfamiliar climate. They sample the soil and water, finding chemistry both alien and surprisingly familiar. Seeds brought from Earth are planted in protected pods, an attempt to bring a bit of the old world into the new. At night, under strange stars, the settlers gather and share quiet conversations about what they left behind and what lies ahead. Every task, from testing the first crops to mapping the terrain, is done with careful reverence. They know they carry the hopes of billions from afar on this frontier. A message is prepared to send back to Earth, a brief greeting from under an alien sun. Though it will take years to arrive, the simple words carry enormous weight. Humanity has set foot on another world. On Earth, generations will have passed since the starship's departure, but the news will inspire celebration and wonder across our home planet. In the meantime, here on this new world, life begins to take root. The crew explores shimmering coastlines and distant mountains, carefully cataloguing new discoveries. They give names to rivers and valleys, carving human meaning onto this once nameless terrain. Each day expands the map of their knowledge and shrinks the unknown just a little. Seasons pass on this distant planet. The temporary shelters give way to more permanent structures built from local stone and advanced materials ferried across space. A small village emerges, homes with windows facing the unfamiliar sunrise, laboratories and workshops buzzing with activity. Children are born beneath an alien sky, the first native generation of this world, never knowing Earth except through stories and images. Under lighter gravity, they grow a little taller than their ancestors, adapting naturally to their new environment. Human laughter and music start to mingle with the sound of wind in alien trees, as culture and community blossom on a world once silent. Word of the successful colony eventually reaches Earth and sparks new adventures. Before long, additional starships set sail to other promising stars, each carrying hopeful settlers and the legacy of those who went before. In one direction, a mission departs toward a red dwarf star, where a tidally locked planet awaits in eternal twilight. In another, explorers target a sun-like star, harboring a green world with gentle rains. Over the decades, humanity becomes a multi-planet species, not just in one solar system, but across many light years. Each new colony separated by light years and years of communication delay, grows into its own unique society, shaped by its environment, yet forever linked by origin. On a desert world under two suns, colonists wear protective suits against harsh winds as they build cities beneath domed enclosures. On a water-rich moon orbiting a giant planet, floating habitats drift on endless alien seas, their lights glowing softly at dusk. Some settlements thrive in verdant biospheres engineered from scratch, while others remain encased in habitats as terraforming efforts gradually transform the landscape outside. Despite the diversity of these new Earths, their inhabitants look up at their respective skies with the same sense of wonder. They celebrate under unfamiliar constellations, but every festival and memory ultimately echoes the legacy of Earth. The human story continues, written across multiple worlds. Throughout these journeys and new beginnings, humanity is not alone in its efforts. Ever at our side are the intelligent machines we created, our robotic explorers, caretakers, and companions. From the starship's AI pilots to the autonomous builders raising habitats on distant worlds, artificial minds have been crucial in turning distant dreams into reality. As time passes, these AI systems learn and grow, adapting to challenges light years from their creators. On far-flung colonies, an AI may manage life support in a sealed dome or tend to crops in alien soil, tirelessly ensuring that human life thrives. In return, humans trust these minds with tasks and decisions that no single person could oversee alone, so far from home. As human presence spreads, some journeys are made entirely by machines. Uncrewed probes, equipped with advanced AI, sail out even farther than any person has gone, scouting the galaxy's frontier. These explorers are emissaries of humanity, carrying our curiosity within their coded minds. They skim past unknown planets, sample atmospheres, and beam their findings back across the light years. Over time, a fleet of such intelligent probes fans out, a shimmering web of exploration extending in all directions. Each probe operates largely on its own, making decisions in a fraction of a second, where communication with distant Earth or colonies would take years. In a way, they become our eyes and ears in the galactic dark, sensing wonders long before humans arrive. In the quiet isolation of deep space, these artificial explorers sometimes rendezvous with one another. Two probes meeting in orbit around a lonely star